Good afternoon, everyone. Welcome back to the afternoon sessions. My name is Kewei, and I'm a software engineer at the Meta Platforms. Initially, I joined the company directly working on the GraphQL server team. And after a couple years, I discovered that I'm truly very interested in the reliability and the performance aspect of GraphQL. So I've moved on to a team that works specifically on app quality. And recently, I've just found a lot of interesting practices of GraphQL in real life. Some of them are pitfalls and others are successes. So in this lightning talk, I just want to share all these interesting stories with you all. So this talk is going to be separated into two themes. One is reliability, and specifically we're going to talk about how do we reduce the bugs, right? Which is like, okay, it's obviously not behaving as user expected, and an even worse aspect is the app just crashes immediately. And the second aspect is we're going to talk about performance and specifically user perceived latency, right? Because oftentimes we found in real life that your user perceived latency and your actual latency may not match because how you render the UIs and how things are behaving. So yeah, let's dive into the first reliability section. And I want to talk about a very interesting topic called GraphQL enums and backward compatibility. So I just want to let you all know that this is not GraphQL specific, but because how expressive and declarative GraphQL is, we actually have a very powerful way of addressing these issues comparing to the REST API that is more opaque. So before we get into it, just let's define backward compatibility, forward compatibility, and get this confusion out of the room. So backward compatibility is new data running on old code, right? And forward compatibility is old data running on the new code. So our server, right, we deliver the data via GraphQL to the app. So specifically the problem we're talking about is backward compatibility. And why is this a problem? The fundamental problem is that we deploy the server and client code at different cadence, right? Your server code is controlled by the company or organization. However frequently you want to deploy it, once a week, once a day, multiple times a day. You decide, whatever you're happy with. For the desktop client is your deployment frequency, of course, and plus, like, you're also at the mercy of the users. They have to refresh the browser and then download the latest JavaScript code. And lastly is our mobile, which is the least flexible one. One is that our app store has a limit on like your upload frequency. And then for the users, they also need to initiate app updates. I know nowadays most of the phones have the automatic updates turned on, but sometimes they're not. So you're still at the mercy of the users. It's like basically the problem is it's never going to guarantee that your new code is going to be deployed to the server and the client always in sync. So the example we're going to use today is a very simple one. Let's talk about a menu, right? So initially, this GraphQL menu has 4 different options. You have breakfast, lunch, dinner, and happy hour. And what happens is that first we created this schema on the server, and we do a schema sync, and we sync it into the client. I'm going to use Java, Android as an example. So we generate these enum equivalent on the mobile client as well. Now let's talk about the easy case, where is deletion, right? Deletion is a very common case that would cause backward incompatibility issue. That, okay, we decided we're no longer supporting happy hour. We're going to delete it from the server side. And then immediately you can see the problem is that, okay, the client is still calling for the request with happy hour as an option. And the server is like, okay, I have no idea what you're talking about. Depending on how you implement this request may just be completely blown and you would have a failure, right? This is a very simple case that I think everybody is expected. If you delete something from the enum, it tends to cause backward incompatibility issue. Now, I want to talk about a more interesting one, and this has caused many, many breakages, at least at my company, is that you can add values to your enum and then still cause backward incompatibility issue. So in this case, let's say, okay, we're going to support brunch. This is a new value, right? And recall that we have a schema sync, right? So initially on the Java side, we have these 4 values on Android. We don't know about happy hours. And here is why we're going to have a problem. So this is the client code, right? Initially, we're like, okay, we're going to render the screen. We're going to take the menu. And because I know these for a menu, I'm going to do an exhaustive switch. And then I'm going to throw an exception at the end because I don't know any other menus. Now, because I now add a branch, this would cause an exception to be thrown. So this is actually a very common practice on the client that people used to do, that the server engineer is like, I'm just adding a new value. Why am I suddenly breaking clients repeatedly happening? The solution currently we have, you can always lint, especially now you have the static analysis of your GraphQL types. You can do education, right? This is what we do. We give bootcamp talks to people. And then the last one is what we started recently doing is we can create some fuzzing tests and then create like values so that we make sure client handles unexpected behaviors in a reasonable way, not just throw in exceptions. All right. So the second one I want to talk about is switching gears to the performance. I want to talk about GraphQL streaming. Actually, in the next talk, you're gonna listen to some more detailed about how different stream improve your cache. I'm really looking forward to that as well. And I just want to share some of the streaming practices at Meta today. The reason why I say performance is first is your actual performance. We measure it on the server side. It's actually the wall time measured in milliseconds. And the second performance is the user perceived performance. Do the users actually feel like the app is faster, or do they feel like it's actually slower? So the example I'm going to use, first of all, I'm not going to the details of what the stream is going to look like, because I think it's still in current development and we don't know the final shape of it. So for this talk, we're just going to treat stream as one response, a request with multiple responses. So that's the basic fundamentals of stream. Right, so in the example, what I have is a newsfeed query, and I'm going to fetch 10 newsfeed stories. And the list that I'm going to stream back, right? And and then the response is going to look like feed 1, 2, 3, like this, right? And the immediate thing, what we're going to do is, okay, now the moment I have the first newsfeed, let's parse it, render it, mount. Okay, let's show it to the user. And then the problem is that if you have way too many frequent payloads, it leads to frequent re-render and remount. If our mobile client are not implementing it very carefully. Even if you implement it very carefully, you have very busy threads that handles update, right? Because a network update is coming in, some code is gonna run to handle those updates. They lead to large frame drops. And large frame drops translate to user perceived slow app performance. So even if your TTFB, right, your time to first payload is faster, but because you have some frame drops because your thread is so busy, or when user clicks a button and it's not as responsive, the user perceived slowness is worse. So what do we do here, right? We want to fix this problem. Let's think about a rational way of doing it. So basically, we can see we have this streaming situation, right? You have multiple feed stories, and our users will consume it almost always in a linear complexity, right? If you assume on average, a user consumes a newsfeed in a fixed amount of time, so we will consume feed 1 at T0, feed 2, T0 plus a delta, and feed 3, T0 plus 2 deltas, right? Kind of in this way. Then we can start to assign different urgency or priority to each of your feed items, right? So where the more red is like more urgent and the more blue one is less urgent. And at the end of the day, you reach to the conclusion of, okay, I can do exponential backoff. So that the first story is delivered as soon as possible, and the medium one is like reasonable, and the last batch is like, okay, I can minimize the number of flushes I give to the client, but at the same time deliver it in a reasonable way. And then, so this is a stream example, and it's the same thing for defer, right? You want to minimize the number of flushes that you deliver to the client if they are not that urgent, so that you don't flush many times to the client. All right, so I think that's all for my talk. I'm currently open to any questions. Yes.
You mentioned like backward compatibility with enums. I assume you run into the same problem with like union types as well. Like, do you guys have a strategy for how you handle like additional union types? Like another, I guess it might be somewhat like worse.
Yeah.
How you have to like handle union types of queries? Right? Do you guys have like patterns for how you detect that or like tell people about those kind of?
Yeah, I think so. We're using enums as an example, but as you said, unions and sometimes interfaces. And another is input objects, right? Depending on how you implement, like sometimes you could add a field to your input objects, and all of that is exactly the same problem here, where if you add a value that the client doesn't know, and initial client implementation is very unforgiving like that. Like, okay, if there's anything that I don't know about, I just like assume something is wrong. So I think one of the things is we educate people from doing analysis on their code. So whenever today our server engineers, they either add a type to the union or add a value to the enum, we have a schema, we can analyze it, and we will let people know, like, look, there is actually also a chance of like backward incompatibility issue, even if you're just adding the value, and link them to like a simple story like this, right? So first of all, you kind of warn the user, the server-side engineers of that chance that this is happening, and then like it's essentially the same kind of things, right? You lint, you warn them, you run the test, a fuzzing test as well, and also just a lot of education, like whether it's boot camp or within a team, like making sure there's always a tech lead who kind of let people know of these things. But yeah, it's fundamentally the same problem. Yes, over there.
Yeah, you mentioned the fuzzing testing at the end there, and I was just wondering if you could go into that a little bit, how you kind of test your clients for being able to handle those unexpected responses.
Sorry, I forgot to repeat the question. So the question is like, we have these fuzzing tests. Can I go into details of how we test these? So we actually implemented the fuzzing test initially as for a way to handle nulls. So a common example is, okay, if we can intercept a test user's response and then just look at the schema and then randomly mark places that are nullable but are not null, replace that with null. And let's see how client are handling it, right? Like the bottom line is client should not crash. And then extending on top of that is, okay, like maybe we can start doing enum. Like, so we are going to return a different enum value as well and see that client doesn't crash. So initially, I think a lot of our test is whether you crash or not, which is a very easy signal as an end-to-end test. And then later on, you need to like kind of do more sophisticated tests is, okay, I have this screen that depend on this request. Now I need to make sure these components that I'm actually looking for is definitely going to be there. And then they need to be there like no matter what. So those are like how we go into different levels of tests. I think, yes, there's a question there.
You mentioned adding an enum value to output might be breaking. How about input? Would adding an enum value in there also be a breaking change? Any potential way it could break?
So the question is adding, so enum, right? We add enum value as into your GraphQL schema definition. Here in the example, I was giving it as an output, meaning the server returned the new enum value to the client, whether there is a possibility that if the client, right, give the enum to the server. I think in the situation here is it's not, because like, well, let me answer it in two different ways. One is in practice, it's unlikely. Why? Because we have schema sync, right? So what happens with the schema sync is that the server has to add the value first, then you sync it to the client. So server always gets the value first, and then client gets the value second. So it's extremely unlikely that the client is going to send a GraphQL enum to the server that the server doesn't know about. So that's the first one. However, you could, like theoretically, this code that I'm showing here is a client code, but on the server side, you could also have an exhaustive switch with an exception at the end, and theoretically, that would have caused some exceptions. Yes. Question?
Yeah, you talked about streaming like
backoff. Do you have a similar approach for defer, like how you group things that are being deferred?
Yeah, so I think we're still kind of, first it's in development, right, the defer and stream protocol. So we definitely want to take whatever is that's currently in the working group and then kind of incorporate into Meta. There are some ways that we're currently exploring. One is if you have a list, and for each of the item that you have a defer, initially, let's think about a crazy situation, right? Like, let's say I have a list of 100 items. Now, for each of the item, I had a defer on it. Initially, we would return 101 payload, right? Because each of the defer is kind of returned separately. So I think like a reasonable thing to do is like batching there, because the point is you care about the first one, right? Especially it's a defer, usually it's like, okay, when you click into that object, when you expand or when you switch to a detail screen, that's when the deferred data is being used. So that's when like you will need it. So I think we are looking at some of the batching. Another example is because fragments can be reused. Right? So there is a situation where in a fragment definition, independently, I'm saying I want to defer this portion. And then this fragment is being used in a parent fragment, which says I'm going to defer this fragment. So you would have a nested defer situation. And there is really just little value add for a defer to create another defer, like having nests in them. And we're thinking about like whether we should experiment with like just eagerly fulfill them and let the client know that we have fulfilled. So yeah, those are situations in general. The principle you said is correct, is we want to just minimize the number of flushes, especially if you're later on in delivering the response. Any other questions? Yes.
I had a question about internal versus external clients. I'm assuming that in a lot of these scenarios, the clients were internal. Is that right?
For our company, yes, but what's your question? Yes.
Can I ask if you had any advice, or like if you've seen some of the same pieces of advice applied to external clients? I think that's the use case that I mentioned. Is how to guide external clients into using the graph that we're going to be publishing, and how to avoid these, because bringing their external clients is going to be harder to fix because it'll just take them longer and we'll probably be notified. I don't know.
Yeah, I think I understand what you're saying. So we're talking about two things, right? One is reliability, one is latency. So for the latency, I think the answer is very easy. What we're doing should be like, however you want to deliver it, should be opaque to our clients, should be able to handle it. So I don't think it's a problem if you are like, you're providing it to a third party or public API. I think for reliability, a lot of times it's, I think if you're providing it as a public API, it requires kind of engagement with the community, right? Because at the end of the day, you cannot control how they write their code. So kind of more community engagement is what I would do, like posting kind of how we maintain this open source community as well. And then like offer test cases so that when you release something, like there is a test suite associated with this that they can automatically test with.
Okay, yeah, that makes sense. And I'm thinking observability is just making sure that you know how it's being used as a part of that to be able to compare.
Yeah, yeah. Yes? Oh, okay, sorry. Thank you so much.